teacher.
Are we good to go?
Yes.
We are understanding, eh?
Yes.
Okay, let me hope I'm not teaching myself. Neha,
Yes, teacher.
have you been watching the videos? That's the task I gave you. Huh?
Yeah, not yet.
Neha,
Not yet.
what are you waiting for? Even
Yeah,
Grace.
I'm also on coaching.
Grace.
Yes. Yes, teacher.
Grace, I've just started seeing you this month.
Yes.
So make sure that you go and watch the videos for previous lessons. Eh?
Okay, teacher.
Yes.
So let's continue. So the only way we can form our matrices is depending on the order of that, depending on the question and the order of the matrix they want us to form. So I can play around with this matrix in any way I want. Okay? Okay?
Yes.
Yes. But when you look at the question, what have they said? What have they said in question? They have said represent the above information in the matrix form. Of which order? Which order members? The order is what?
3 by 2.
What does it mean? Which means we should form how many rows?
3.
And how many columns?
2.
So how should we put ours now? We have how many units in the farm?
3.
Which means the 3 columns, the 3 rows are going to be formed from the what? From the units, not so?
Yes.
Then the 2 are going to come from where? From the products or from the farm, not so? The eggs and the?
Yes.
And the broilers.
The broilers.
So let's put it here. This is A, B, C. Then I just put a bracket there. I think that.
Yes.
These are eggs, then what? Eggs, then what?
Broilers.
Broilers. Unit A. Produce how many tray of eggs? 30.
30.
What about broilers? 20. I think that. Come to B. What about B?
40 eggs, 15 broilers.
15. What about C?
35 and 10.
Yes, this is a 3 by 2 matrix, full stop. Okay?
That's all.
Yes, that's all. That is it. That's what they want. We have formed it. Okay?
20.
Yes.
What if? What if they were asking for? Let's adjust it. What if they're asking for 2 by 3? What if they're asking for 2 by 3? Which means we are going to have how many rows?
2.
How many columns?
3.
So which means the 2 rows must come from where? From the product. The eggs.
From the products.
Eggs. And then what?
And the broilers.
And the broilers, like that. Then A, B, C.
B, C.
I think that.
Yes.
So this one will be 30, 20.
30, 20.
40,
40, 15.
35,
35, 10.
This one is 2 by?
3.
Are they the same?
No.
Yes, very good. Take note of that. Take note of what? That. Go to Roman 2. What do they want in Roman 2?
Form a 2 by 1.
2
matrix.
Order. 2 by what? 2 by 1 matrix.
Matrix.
2 by 1 matrix. So where will the 2 come from?
From the product.
Then the 1 will come from where? The cost, not so?
Yes.
From the question I've said, if a tray of egg, if a tray of egg costs how much? 3,000.
3,000.
And a broiler how much?
4,000.
So which means here I'm going to have eggs, not so? Then I'm going to have
the broilers.
The cost is it? This is 3 what? 1,000. Then this is
4,000. 1,000.
Answer, full stop, nothing else. That's our answer. Okay?
No more struggle.
What is the name of this matrix? There's a special name given to this matrix. What's the name of this matrix? Who can remind us what's the name of this matrix? Where we have only one column. We have only one column. What's the name of that matrix? It's called a column. This is called a column what?
Matrix.
It's called a column what? Matrix. But I can also change this one. What if I decided to change this? What if it's 1 by 2? Who can form it? What would be that? 1 by 2 matrix. Who can form for me a 1 by 2 matrix? It will be 1 row and then how many columns?
2.
How will it come from? So we shall have, it will be like this. It will be 3,000, not so? Then what?
4,000.
So this is 1 by
2.
1 row, 2 columns. What is the name of this matrix? What is the special name given to this matrix? This one is a column matrix. This is a row matrix. Good. This is a row what? Matrix.
Matrix.
Good. Are we together?
Yes, teacher.
Go to Roman 3. What do they want in Roman 3? Roman 3. They said find the sale of the what? Of the farm. If all the eggs and the broilers were what? Were sold. So what are you going to do? You are going to multiply, not sir? You are going to what?
Multiply.
So using, you come and say using matrix what? Using matrix what? Multiplication. Using matrix multiplication. So you are going to have the production which was we had 30, not so? 20, 40, 15, 35, and 10.
And
This one was 3 by 2. Time. The cost. What was the cost? The cost was 3,000. And then what?
4,000. 4,000.
4,000. This one is 2 by 1. Members, are these two matrices, are they compatible? Are they compatible?
Yes. Yes.
Yes.
Why are they compatible? Why?
That
They have the same number of columns.
The first matrix has this, because the first matrix has how many columns? Has 2 columns.
2 columns.
And then the second matrix has how many?
Has 2.
2. So
2 rows.
So what is the answer? The answer we are going to get must be of what? What will be the order of the the final
3
answer?
by 1.
Excellent.
3 by 1.
It will be 3 by
1.
by 1. So let's go ahead and multiply. We said we multiply matrices row by
column.
Row by column. So let's start multiplying now. So 30 times 3,000. What do you get? That is what?
900,000.
That is 90.
90,000.
90,000 plus
9,000.
20 times 4,000. What do you get?
90,000.
80,000.
80 what? 1,000.
1,000.
Is there anything else? We close that. That's the end. Okay. Okay. We come to the second. We come to the second row. 40 times 3,000. 40 times 3,000. What do you get?
1,120.
Plus 15 times 4,000.
120,000.
15 times 40. I mean 15 times 4,000. What do you get?
60.
Is 60 what? 60,000. We are through with that. We come to the last one. 35 times 3,000. 35 times 3,000. What do you get? We get 105.
140,000.
105,000. Then 10 10 times 4,000. We get 40 what?
40,000.
So can we get our final answer now? 90,000 times 80 plus 80,000 give us 100 and what? 170. 120 plus 60 give us 100 and 180.
180.
Then this one will be 140. 140 what? 45.
5.
This is farm unit A, unit B, unit what? Unit what?
C.
C. But they
C.
want from the old farm. From the old what? From the old farm.
Whole farm.
But this farm, from this farm has how many units? Have 3 units. So which mean to get the total sale will be, so total what? Total sale will be, you add from unit A plus unit B plus unit what? C. So which will be, selling now, you put 170,000 plus 180,000 plus 145,000. So what do you get? What do you get when you add all of them? So 170 plus
495,000.
is what?
495,000.
495,000.
Like that. Like what?
Like that.
Part B. Part B. Members.
Yes, teacher.
Before we go to part B, let me emphasize something here. But if they were asking from each unit, they may ask you what was the sale in each unit? In each unit, which means for unit A was going to be
170.
in unit B was going to be
180.
in unit C is going to be
145.
But now, according to this question, they're asking for the whole farm. For the whole what?
Farm.
For the whole farm. That's why we added. That's why we what? That's why we added.
We added.
Are you together? Let's go to part B. In part B, what do they want? In part B, what do they want?
180,000.
Find the total income from the sales of the farm every month.
145.
Part B of the question. Part B.
If the farm
Charges.
If the farm
If the farm what?
If the farm charges 17%,
So
find the total income
what is this one?
of the farm.
What is VAX? This one is it?
Yes.
This is value.
Value added tax.
Value added what?
Added tax.
Value added tax. So this farm was paying how much on tax? Was paying 17%. 17 what? Percent. Of the what? Of the what? Of the sale.
The sale.
Okay? Are you together?
Yes.
So which means for you to find, because when you look at the question, they're saying find the total income from the sale of the farm every month. So which means they're asking you to find the net income after removing the tax. After removing the what? The tax. So how much is the tax now? So our tax will be, tax is 17% of the what? Of the sale. So which means 17 over what? Over what?
100.
Times what? What was the sale? The sale we got was 490.
Total sale was 495,000.
So how much will go on tax? Tax will be? Can you calculate for me that? How much? How much?
84,150.
That's the amount the person will pay on what? For tax. Okay?
Tax. Yes.
Right? Yes. But is that the income of the company, of the farm? Generated from the farm? No. That is only the what? That is the tax. This is the tax. So now if you want to find the income, what do you do? So income will be the total sale, will be the total what? Total sale minus what? Minus what? Minus tax. I think that. Our sale was 495 minus 84,000 100. So what do you get? What do you get?
410,000.
Huh?
410,000. 850.
410,800 and what? And 50.
50.
So that's the what? That's the income. That is the what? The income.
The income.
Okay?
Yes.
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 Any question on that? I'm very loud. I'm loud and clear, right?
Yes.
Yes.
Please feel free. We are doing correction. Feel free to ask me what was the challenges you got when you are doing the paper. So this is the time you have for asking me. You say, teacher, hey, for me, I thought it was like this. Hey, I thought it was like that, like that. So that we leave no room for mistakes. We leave no room for mistakes.
Mistakes.
The senior twos who did this paper. Have you seen where you went wrong? All right. So let's summarize with number 13. The last question there. Number 13. Number what?
13.
Question 13 is coming from which angle? It's coming from probability, not so?
Probability.
It's coming from probability.
Probability.
And we said probability of any event is equal to the number of events divided by the sample
Space.
sample space. That's the thing you must take note of. Whether you know it or not, you must first write it there so that before even you read the question, whenever you say any question on probability, first write this statement down. Probability of any event is equal to the number of events divided by the number of sample space. And it's also very important to remind ourselves that there is no negative probability. There is no negative what?
Probability.
So whenever you are doing any question on probability and you happen to get a negative value, say, please, I'm already wrong. Don't even waste your time submitting the work. Just know you're already what?
Wrong.
And if you get any answer more than one, any answer and you are doing probability and you got any answer more than one, just know you're already wrong. So for any event, for any what? For any what?
For any event.
For any event. For any event. Okay? Okay?
Yes.
Don't copy from me. These are maths language, eh? These are maths language. For any event, okay? Okay? Probability must be less than or equals to 1, less or equals to that. Okay? So this one means there's no probability, there's no negative probability, and there's no probability beyond what? 1. So it must be between 0 and 1 inclusive. Between 0 and 1 inclusive. Okay?
Yes.
We discussed very many items there. We discussed very many items. We talk about independent events. We talk about independent events. What did we say about independent event members? We said independent events, these are events where the occurrence of one does not affect the occurrence of the other one. Okay?
Yes.
What are the examples of independence event? What are some of the examples? Some of the examples we can say. Now, which name should I use? Let me see, which name should I use?
Neha.
The probability. The what?
Ability.
Or the chance of Neha passing mathematics will not affect. Will not what? Will not affect the chance of Krenema passing mathematics. They are absolutely independent. Because we are all independent. That's why you sit for different exams. You sit for different papers. Okay, you sit as an individual. You don't sit as a group. I think that.
Yes.
I've seen that, members. Have you seen that? Those and we call them independent events. Okay. What about dependence events? Dependence event, which means the occurrence of the other event depends on the other one. Depends on the what? Depends on the other one. What are the examples of this? Now, like for you to pass mathematics, you need to know English. You need to know what?
English.
So English, you cannot do mathematics without what?
English.
That's why even if I'm teaching, even if your teacher is teaching you history, even if you are teaching you physics, the what they use, which language do they use? They use what? English.
English.
Which mean history, physics depends on what? Depends on what? Depends on English.
In English.
Are you together?
Yes.
So you should know. Then we also talk about what we call mutual event. Mutual what? Mutual event. These are events which they will never occur together. They will never occur to what? Never occur what? Together. Like which one? I remember when we were discussing, someone gave us a very good example. What are the examples of mutual events? Being alive and what? Dead. Can you be alive and dead at the same time?
No.
No. So those are mutual.
No.
Those are mutual what? Events.
Mutual
Events.
Those are mutually exclusive events. So we are saying A intersection B, the probability of A and B occurring together is what? Is what? Is 0. Intersection means they will occur together. Okay?
Yes.
But for mutually exclusive events, they will never occur together. They will never what? Occur together.
Together.
Also, here for independent events, the probability of A intersection B is equals to the probability of A times the probability of what? Times the probability of B. Okay?
Yes.
Yes. So those are the things we discussed. After that, we went ahead on how to generate a sample space. We went on how to generate a sample what? Sample
space.
Sample space. What do we use? We said throwing a what? Throwing a what? A dice. No, sir? We talk of tossing a coin. Tossing a what?
So doing what?
Tossing a coin.
No, the first one.
Throwing. The first one is, this one is throwing. Okay? Okay?
Okay. Yes.
Yes, a coin. I mean a dice. Okay? So we said for a dial has how many sample space members? What's the number of sample space of a dial?
Six.
A dial has 1, 2, 3, 4, 5, and what? And what? And 6. Okay?
Yes.
Yep. Yes. Then a coin. Sorry, a coin. A coin has only the head or the what?
The tail.
Head or the tail. That is if only one. If only what? Only one. So what is the number of sample space? For here, the number of sample space is what? Is 6. Here, the number of sample space is what? Is what?
2.
2. Why? Because we have 8 and tail. Here we have 1, 2, 3, 4, 5, and 6. So when you count them, there are 6. Okay? So if you double them,
yes.
If you have 2 dials, you have 2 dials, which means the number of sample space will go to 30. Will go to 30 what?
6.
36. I remember we generated that. If you have 2 coins, the number of sample space will go to
4.
4. You remember that? Yes. After that, we also went and talked about probability tree diagram. Probability tree what?
Diagram.
Tree diagram. Where we said if this is a container, and we have two items, A and B. A and B. This is also A and B. A and what? A and what? A and B. So what you have drawn here, this is what we call a probability tree diagram. So when you look at this one was taken, this experiment was done how many times? Was done how many times? 2 times. Was done 2 times. And we also said whenever you are doing a probability tree diagram, each branch, each what? Each branch, like this is the first branch. When you add the probability of this, must give you 1. When you add the probability of this, must give you 1. If you add the probability of this, must give you 1. And when you combine all of them, must also give you what? Must also give you 1.
1.
Are we together?
Yes.
Are we together, members?
No. Yes, teacher.
That was just a quick reminder. Now let's go to the question. Let's go to question now. Let's answer that question. So can someone take us through that? Question number 13. Let's answer now that question. After reminding ourselves.
A box contains 4 red
Uh-huh.
and 6 blue pens.
So we have pens. So here in this box, we have only pens. We have only what?
Pens.
And there are how many colors?
2 colors.
We have red
And blue.
red and what?
Blue.
Red and
Blue.
blue. Red and blue. Red there are how many? Red there are
4.
Then blue there are how many? Blue there are how many?
6.
There are 6.
6.
Blue.
So what is the total number of pens? Total number of pens in the box. Total number of pens
10.
is 4 plus 6, which will give us what?
10.
Which is what?
10.
10. Continue.
A pen is picked at random from the box and not replaced.
Which type of scenario? We said we said we have 2 types of selection. We said we have 2 types of what? 2 types of selection.
Select
We have with replacement or without.
without replacement.
Without replacement. Without what? Replacement. What happens during without replacement? The number keep on what? The number of items keep on what? Keep on what?
Decreasing.
Decreasing. Then with replacement. With what?
Replacement.
The number of items remain the what?
The same.
The same. Because you are
remain the
picking,
same.
and then you are putting it back. You pick and then you pick, then you say, I'll pick a blue pen. Let me take it back. Okay? Okay? You pick, if you know that you are pick a blue pen, you put it aside, you pick, and then you put it aside. So like now, if this, assuming this was our box, and in here, how many items do we have here?
2.
So what is our sample space? Our sample space is what? 2, not sir?
Yes.
The sample space means you cannot pick from outside. Because there are 2, which means I expect only 2 items to be inside that box. Okay?
Yes.
So what is the probability of me picking blue? What's the probability of me picking blue? How many blue pens are in? How many blue pens are here?
1.
1.
How many red pens are here?
1.
So what is the probability of me picking blue?
A half.
Is a half, not so.
1.
Is a half, not so.
Yes.
Because I have there is only 1 blue pen, so 1 over the sample space. 1 over the sample space, which is what? 2. What about the probability? What is the probability of picking a red pen?
1.
Is 1?
I have 2.
Is 1 out of 2. Is 1 out of what? Is 1 out of 2. Good.
I have not understood.
We are saying if this is a box, assuming this is the box they are talking about. Okay? Okay?
Yes.
And in this box, how many pens are you seeing inside this box? How many pens are you seeing inside the box?
2.
There are 2. How many blue? How many blue pens?
1.
1. How many red?
1.
So what is our sample space?
2.
The sample space is what? 2. So I'm asking now, what is the probability of me picking a blue pen? It's going to be 1 over what?
2.
1 over 2. What is the probability of me picking red? Is 1 over?
1 over 2.
1 over 2. Okay?
Yes.
Yes. Good. So, but in this box, we have 4 red pens. And then 6 Blue pens.
It's blue pens.
Now they've said one pen is picked after the other. Another pen is picked at a random from the box again. So which means how many pickings were here, members? There were two pickings, no sir? There were two what? Pickings. Okay? Okay?
Yes.
The first one
Yes.
and then the what? The first one and then the second
Last.
one.
And one.
But all in all were without what? Without what?
Replacement.
Without replacement.
Replacement.
So can we draw our probability tree diagram now? So you said using probability tree what? Tree what? Tree diagram. So let's start drawing. Give enough space. So this is the box. I have red and then I have what? Blue. So the first one, the first picking, this is the first picking, members. This is the first what? This is the first what? Picking. You can either pick blue, you can either pick red or what?
Blue.
Blue. So what's the probability of picking red? Is 4 out of?
4
10.
out of 10.
What's the probability of picking blue? 6 out
6
of?
out of 10.
6 out of 10. That was the first one. That was the what?
First one.
The first one.
Then they said another pen was also what? Another pen was also picked. We are going for the second one now. The second picking. The second what?
Picking.
The second picking. You pick red, blue, red, blue. Okay? Okay?
Yes.
So here you must now here you have to be very attentive here. In the first branch, in the first what?
Branch.
Which is this one. I'm going to assume that I've picked a blue pen. I mean, I've picked a red pen. I've picked a red what? Pen.
Pen.
So which means if I pick a red pen, which means the number of red pens will reduce to what?
2, 3.
Then the number of pens in the box will reduce to what? To 9.
9.
So which means here we've got 3 out of what? 3 out of?
9.
9.
I did not pick blue. I did not pick what?
Blue.
Blue.
Which means blue will still remain 6 out of what? 6 out of?
10.
Then when I come to the second,
Nine.
when I come to the second branch, when I come to the second what?
Branch.
I will assume that I've picked a blue. Remember here we assume we have picked a red, not sir?
Yes.
Then here we assume that we have picked a what?
Blue pen.
Blue.
Now, if you have picked a blue, what is the probability of picking a blue now? It will be
5 out of 8.
5
Five.
out of 8.
5 out of 9. 5 out of 9 because you are still in the same range. In the second picking. In the second what? Picking.
Picking.
Are you together, member?
Yes.
Yes.
I did not pick red, which means red will still remain what? Red will still
3
remain
out
4.
of 9.
Red will still remain 4 out of 9.
Teacher.
Teacher, we are confused.
I'm saying, okay? In the first one, in the first branch, you assume that you have picked what? Blue, not so? I mean red, not so?
Red.
If you have
Yes.
picked red, which means red will reduce to 3, not so?
Yes.
Blue is still remaining what? Blue is still remaining 6. Now in the second branch, you assume that you have picked blue. You did not pick red. You have picked blue, but you didn't pick what?
Red.
So red was still how many? 4.
4.
But red, I mean blue pen will reduce to what? Will reduce to 5. 5 out of 9. I think that. So this is our second.
Yeah.
That was our second picking. Like that. Okay.
Teacher, why didn't we say 5 out of 8?
Now, if you have said 5 out of 8, which means that was the third picking. That would be the third picking. Where now the number of items will reduce to 8. Okay?
Okay.
That
Yes.
Yes.
That would
so
be the,
all have to be out of 9.
because we are picking one at a time, one pen at a time, one pen. You are not picking 2 pens at a go. You are picking only 1 pen. Okay? Okay?
Yes, teacher.
Yes.
Yes. So this one is presenting red and what? And red. Not so? This
Yes.
one is presenting red and blue. This one is presenting blue and red. This one is presenting blue and what? And blue. I said before even you look before you look at the question, first simplify this. First what? Simplify this.
Simplify.
So how do you simplify? By multiplying the probability of along each branch. Along each what? Branch. So red and red is going to be 4 out of 10 times 3 out of 9, which will give us what? Will give us 12 out of what? 12 out of 90, not so?
Yes.
This and this time this will give us 24 out of 90, not so?
Yes.
This and this will also give us 24 out of 90. Then this and this will give us what? 30 out of 90, not so?
Yes.
Now, before you go and look at any question, I said when you add all this probability, the total probability must be what? The total probability must be 1. Must be what? 1. So can you prove that? So since they have the same denominator, can we adjust the denominators? Let's add the denominators. 12 plus 24 plus 24 plus 30. What do you get? Is 90. 90 out of 90 is what? 90 out of 90 is what?
1.
Is 1. So which means we are correct. Which means we are what? We are correct. Are we together, members? Are we together?
Yes.
Now let's go and answer the first part of the question. The first part is saying the first pen is what? The first pen was blue.
Yes.
The first pen was what? First pen blue. So which means where do you get this one? From the first picking. From the first what?
Picking.
The first pen was blue. So what's the probability of picking blue? Is what? 6
5
out of
9.
I mean here. First picking. The first picking here was
6 out of 10.
6 out of what? 10. Can you simplify? Can you simplify that? If you simplify that, you get by 3. I mean by 2, we get 3. 3 over what? 3 over? 3 over 5. Not so?
Yeah.
Yes.
Because they're saying the first one, the first picking, which means I'm talking about the first picking. The first pen was blue. Where do you get it from? From the first picking. Are you together?
Yes.
The second one is saying probability of what?
Both pens were red.
Both were red, which mean both were red, which mean probability of getting red and red.
Red.
Red and red is what? We got is what? Is 12 out of?
12 out of 90.
So it's 12 out of 90. Can you simplify that? Simplify that. Well, if you simplify, you get what? 2 out of?
2 out of 15.
2 out of 15. Members, this one is different from tomorrow. They may say, what is the probability of the same color? Same what?
Same
Color.
If they say the same color, which means you are going to add what? Red and red plus blue and what?
Blue.
I think that. I think that. Which means you are going to have 12 out of 90 plus blue and blue is what? 30 out of what?
30 out of 90.
Which will give us what? 40? 42 out of?
42 out of 90.
Are there common factors there? Reduce them. Is what? 7 out of?
15.
15.
They are not the same. This one, if they were asking for the same color. Okay?
Yes.
This one, they were asking only for red. This one, they were asking only for what? For red.
Red.
For red.
Then the last one they're asking for? Probability of what? Different?
Colors.
Different colors. Which means you can get blue and red and blue, or blue and what? And red. Different
Red.
colors. Different colors. Okay?